My name is Owen Mason, and this is my Create Your Own Adventure lab. The purpose of this lab, I will analyze the collision and momentum of two pool balls and track their velocity and positions. One ball started from rest and the other ball was rolled into it, causing a collision, and both balls developed new velocities. I utilized Tracker to analyze the movement and positions of the balls in ideal conditions and calculated the velocity of the red ball based on the black ball's final velocity using the momentum principle. The main concepts in this course utilize Newton's first law. From this law, from integrating this law once, we get the velocity update equation, and from integrating that law again, we develop the position updating equation that we'll utilize to update the ball's velocity and position during the collision. The other major concept is conservation of momentum and collision principles. That states that total linear momentum is conserved during a collision. I utilized Tracker to keep track of the positions of the ball during the collision and after the collision. The picture of after the collision is shown right here. And through this tracking of the positions of the balls, we develop these graphs that track the X position versus time, the Y position versus time for the black ball, and the X position versus time and the Y position of time for the red ball. We utilized GlowScript to create a predicted model of the collision, ignoring friction, based on the initial velocity of the black ball and the final velocity of the black ball after the collision. While loop, updating the positions of each ball based on the initial velocities of each one, the red one was just 0, till the collision occurred at 0.067 seconds. After this collision, I updated the new velocity of the black ball, which we found using our tracker information. And by the momentum principle I stated earlier in the concepts, we were able to figure out the velocity of the red ball after the collision, which was just the black ball's initial velocity minus its final velocity. Because the masses are the same, the masses cancel out in this equation. Then using this velocity, in a second while loop, I was able to update the position of each ball based on their newfound velocities. Examining my GlowScript, I was able to extract data of the X positions and Y positions from the collision of the balls in a predicted model. I then compared this data to the data I developed through Tracker. The orange dots are the Tracker data, and the blue are the GlowScript data. This is for the red ball. As you can see, the data are fairly similar, almost very similar for the X data. However, for the Y positions, you can see it starts to deviate a lot as the time goes on. This is most likely due to the surface being on some sort of an incline, causing the red ball to travel faster in the Y position than I predicted in the GlowScript. GlowScript data and the Tracker data for the black ball. For the black ball, the predicted and the Tracker data are very similar and much more accurate than the red ball. This is because the Tracker data utilized the final velocity of the black ball, so it has a much more accurate prediction of its position after the collision. After examining the data, we can figure out if this collision was elastic or inelastic. We figured this out by figuring out if there was a change in kinetic energy. To figure out the change in kinetic energy, we figure out the final kinetic energy minus the initial kinetic energy. The final kinetic energy of the system is the kinetic energy of the black ball and the kinetic energy of the red ball. And the initial kinetic energy of the system, because the red ball has a 0 initial velocity, is just the kinetic energy of the black ball with its initial velocity. After plugging all the data into that equation, we figure out that there was a slight change in kinetic energy. This means that the collision was inelastic. Objects can collide together and change position and would have different velocities based on their types of collisions. One would be, what if the balls stuck together when they collided? What would happen to the velocities and what would happen to the position of the balls? we were able to figure this out by looking at the momentum principle. And the momentums before would equal the masses added together and multiplied by a final velocity. We were able to figure out this final velocity by plugging in the numbers because we have all this data, and we figure out that the final velocity, because the two masses are the same, is just half the initial velocity of the black ball.